let's begin our discussion with circular motion. So, what is circular motion? When we're talking about circular motion, we're talking about an object moving around the circle. Okay? If an object is moving around the circle, we call it circular motion. There is a force which is directed toward the center. This force is what we call centripetal force. Okay? Most important thing you need to understand is that centripetal acceleration is given by the v squared divided by r. Therefore, we can conclude to say the force according to Newton's second law is equal to mass times acceleration. So if force is equal to mass times acceleration, then we can clearly see that the centripetal force will be equal to the mass times centripetal acceleration. At the same time, we know that centripetal acceleration is given by v squared over r. I can replace centripetal acceleration with v squared over r. This is the formula for centripetal force, and that is the formula for centripetal acceleration. Is that okay? Now, now, now. Another thing we have to take note here is that we also have, when an object is moving around the circle, we have got what we call the angular velocity. Angular velocity is directed in that manner. So we have got what we call the linear displacement to be given by angular displacement times r. The v, or the v, which is the linear velocity, is given by angular velocity times r. Acceleration is given by angular acceleration times r. Guys, you can't run away from these formulas. These formulas are very, very important. Okay? These formulas are very, very important. If I have my linear displacement, I want to find the angular displacement, I have the radius, I can use this. If I have my velocity, I want my linear velocity, you can just mute your mic. If I have my linear velocity, or if I have my angular velocity, I have my radius, I can use this to find the linear velocity. Are we together? Okay. Now, what else are we supposed to talk about here? Okay, so there is also what we call the relationship between the angular acceleration, or the translational motion and rotational motion. The relationship is that the formulas which we have, like the v final is equal to the v initial plus at. This can be written as, now in angular, is going to be angular final velocity plus O is equal to the initial plus a. Now a in this case is going to be alpha, like that. Then another one is d is equal to v initial times t plus half at squared. In rotational motion, this can be given by d is theta, that will be this times t. T doesn't change, then you have this. Next we have the v final squared is equal to the v initial squared plus 2a d. So this is the alpha final is equal to alpha initial to alpha, the d is theta. This relationship is very important. You need to know these formulas. I'm going to summarize rotational motion, everything. I'm going to explain everything. We solve all the questions. No more excuses. Right? From where we have reached so far, we can solve some questions, which are these. I think my headsets are having issues. Okay, so the first question, this is 1015 though. A cylinder of radius 20 centimeters is rolling along a horizontal surface with a constant speed of 80 centimeters per second. What is rotational speed of the cylinder? 5 marks. From the formulas, from what I've explained so far, we can get these 5 marks. We have the radius to be 20 centimeters. We have the speed to be 80 centimeters per second. Our goal is to find the what? So this speed, I'll call it V. Our goal is to find this. Which formula can we use to find this? 5 marks. Just plugging in the values here. Tell me. I said if you don't have a calculator, you have to leave this meeting now. From the explanation I gave you, I gave you this formula to say V is equal to WR. Our goal is to find the W. I'll divide both sides by R. Like this. These formulas, it's not physics without using these formulas. It's not possible. If you want, you can convert those. But if you don't want, since this is in centimeters, this is in centimeters, you can plug in direct. You'll be able to find the answer. But if you want, you can convert. That is just okay. So if I don't want to convert, I will say 80 divided by 20. So I have 4. Now this is in rad per second. That is 5 marks, which I have there. Have you seen, guys, what I've done? Now, meaning I'm done with that part. Now, the next part I want us to talk about is not really this. This I'll come and explain with the time we're going to be talking about rotational, work energy, and momentum. But I want us to talk about part C because I've explained this as well. An object moves at a constant speed of 9.0 meters per second in a circular path of radius 1.5 meters. Find the angular acceleration of the object. Angular acceleration is, so now we have got the speed, which is the V, which is 9.0 meters per second. R is 1.5 meters per, meters just. We want to find this. Angular acceleration is the same as centripetal acceleration. Angular acceleration is the same as the centripetal acceleration. In this case, since I've got the V and R, what is the formula to find the centripetal acceleration? V squared over R. Our V is 9 squared, 1.5. I said if you don't have a calculator, even me I don't have a calculator, but me I can't leave because I'm the one who is giving you a presentation. But you don't have a calculator, you can go. You can leave the meeting. What is the answer here? 54 rad per second squared. That's 8 marks. Then are you telling me that these things are hard? Now, listen. Sometimes, especially physics, let me emphasize on physics. Physics, you should not be intimidated when you look at the marks here. 8 marks, do you think someone, you'll be like, no. But the best way to do here is come up with a free body diagram. An object moves with a constant speed, circular path. You come up with a free body diagram. Here is a circular path. The angular velocity is in that direction. Okay, the linear velocity is in that direction, which is V. Now, in this case, you want to find the what? The angular acceleration, like that one. Then you come up with the radius is there, you come up with a free body diagram. There is not, you can also use another method to find this, but which is going to be, I don't know that method. If there is any, then I don't know. But this is the best way on how you can handle this question. You come up with a free body diagram, just come up with a circle, the angular acceleration where it's going to be pointing, the radius and everything. 54 rad per second squared, 8 marks. Okay? That is circular motion. Understand more about circular motion. Now, another thing I have to explain about circular motion is have you guys gotten on how I've managed to get the answers for the part A and C? Hmm? Okay, yeah. Which 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 one, sir? Oh, oh. You you are doing math. Oh, and math. You are doing physics 1010 or 1015. Ah, it can't come. Yes, just leave it. But for 1015, this is coming. But for the sake of concept, that's why, that's the reason. Because what I'm explaining right now is the same thing we are going to be using. It's the same thing we use to answer question 1 for 1010. It's the same thing we're going to be using to answer the question, which is this one. This one. Now let me explain about conical pendulum. Conical pendulum, I'm going to crack everything and then we answer this question. Everything. This is what we call a conical pendulum. Now, this conical pendulum, only that I don't have a rope right now. I wanted us to do an experiment. I wanted us to do an experiment, but anyway, I don't have a rope. So, if this is our conical pendulum, from what we can see here, this is the length of the string, and that is our bulb. The distance from there to there is the radius. Okay? Now I'm going to say this is length, just like that. Okay? Now let's assume that we have been given length but we don't have the radius. When an object is moving around the circle, it is moving in x direction. What I'm going to do, guys, right now is I'm going to get this one as a free body diagram. What do I mean? Allow me to put this one here, like that. So this is my bulb. Then what I'm going to do now is, this is in free fall. There is a force of gravity which is trying to pull this guy down. That is what I'm going to say mg. Okay? This mg, it has to support this guy, meaning it's going to have that force and that force. The force supported by the rope is what we call the tension force. I'm going to call this one as Ft, meaning the tension force. So according to the rules of the angles, I know that if I have something like this, the angle which is here is the same as the angle which is there. What does it mean? Remember, here I have something here. I have got an angle which is 30, which is here, meaning that 30 which I have there is the same as the 30 which I have on top here, down here. Okay? Next, this can be written as ftx, then this one fty. Fty. Guys, using SOHCAHTOA, my ft is going to be opposite, meaning my ft using SOHCAHTOA, my ftx will be equal to ft cos sine theta because of its opposite. Using SOHCAHTOA again, my fty will be equal to ft sine theta. Please ask me questions why I'm getting sine. Oh, this is supposed to be cos in y. Why I'm getting sine in x-axis? If you're having challenges, please ask. Because under vectors, you only know that x in x, the x component of the vector is always cos, not so. But in this case, it's different. Why? Because I can clearly see that opposite here is f. So if I use opposite is sine, sine is equal to opposite over hypotenuse. That's why I'm using sine here. Then this object, guys, it is moving in x-axis. It is moving like that. You understand? So it is moving like that, just like that. It is not moving in y-axis. Okay? Therefore, the summation of all the forces in y direction, when we add them, they're supposed to give us 0. So I'm going to say the summation of all the forces in y direction, when I add them, I'm supposed to get 0. But what force do we have? We have got Fty pointing upward. Then mg is pointing downward. I'm going to say minus mg. Since the net force is 0, this object is not moving in y direction. I will replace this with 0 to be equal to Fty minus mg. Like that. I can shift Ft to the other side or mg to the other side. Then it's going to be mg is equal to Fty. But I can write this by starting with Ft. So Fty is Ft cos theta is equal to mg. Let's call this as equation 1. The way I've derived this equation 1, please ask. You always do this for any type of conical pendulum, what I'm trying to come up with. And we'll end up having one thing which can answer all the questions of conical pendulum. Yes. You can just ask because I'm not able to see. Even if you raise the hand, I'll not be able to see. So you can just unmute yourself and then ask if you've got a question. Okay, cool. Thank you. Sorry. When the angle in the direction is sine theta. I think I still don't get your question. Um, you were there when we were doing this, when I was coming up with these guys. So using SOHCAHTOA, the angle is here. I know you are confused. Let me show you this. If you happen to have something like this, okay. If you happen to have something like this, and then the angle is here. This is x and this is y. Okay? Or let me say, let me not complicate things. Let me just put this is v. So let's put that feet, meaning this is vx, this is vy. Not so. So if the angle is there, we know that the opposite, we use SOHCAHTOA. That's why under vectors you always say in x is cos theta. It's because you always consider the angle from positive x axis. Are you still here? Okay. So have you seen what I'm trying to do? Now the angle is down there. So what will be our sign? Hmm? What are you saying? Now, what is happening here is that this is opposite. So that's why in Vy we say V sine theta because the angle is here. Now in this case the angle is there. So the opposite is x. So that's why in x that's where we have sine because the angle is down there. Have you seen it? Hmm? Okay, perfect. Then next I'm going to say let's go to the forces in y direction. The summation of all the forces, or in x, sorry, in x direction. This object is moving in x direction. We expect acceleration to be there. So we have got how many forces? The only force we have in x direction is ftx. Okay? But since there is acceleration, this is going to be replaced by mass times acceleration. But since it is under circular motion, that acceleration is centripetal acceleration is equal to ftx is the same as ft sine theta, like that. Then centripetal acceleration, we said centripetal acceleration is v squared over r. I'll replace it by that. I'll say m v squared over, or is equal to ft sine theta, like that. So we'll call this as equation 2. And most of the times this question comes, they'll give you 10 marks. You do what I'm doing right now for you to get all the 20 marks. I'll get rid of this part here to create space. Now, in most cases, we're not interested in the tension force. But in a case where they're going to ask you about tension force, you are going to know, I'm going to show you how to do that. So I'm trying to eliminate tension force. In the first equation, I'm going to make Ft as a subject of formula. So the first equation is Ft cos theta to be equal to mg. We divide both sides by cos theta, even here by cos theta. So I'll say my Ft will be equal to mg divided by cos theta. Now when you want to find the tension force, you can use this formula now to plug in the values when you have the theta and everything to find the tension force. Now in this case I want to find how fast the bulb is going to be revolving. Okay? Meaning I'm trying to make V as a subject of formula in that case. You understand? So now what I'm going to do here is I'm going to replace where there is tension force in the second equation with mg divided by cos theta. As simple as that. So where there is ft, in this case it is here. So I'll say, you have a question? Yes, ask. I didn't say mass over acceleration, sir. Okay. Oh, I didn't include R. I'm supposed to put R down. Thank you. Thank you. The good observation. I'm supposed to put, because centripetal acceleration is V squared over R, so I'm supposed to put R here. So where there is ft, I'm going to put mg cos theta. Oh, yes, I'm going to put mg divided by cos theta. Let me just get rid of this part here. So I'll say mv squared, I'm writing the second equation, divided by r is equal to, where there is ft, I'll put mg over cos theta times sin theta. This can be written as mv squared divided by r is equal to, this is mg, then sin theta divided by cos theta. So what is sin theta divided by cos theta? Tan theta. So this will be now mg tan theta. Now we can clearly see that mass appears both sides. So this side and this side I'll cancel mass. Okay? So I'll end up having this. This is the general one for all conical pendulum. So I'll have v squared over r is equal to g tan theta. Then I can make v as a subject of formula. If I cross multiply, I'll have v squared is equal to r times g tan theta is r g tan theta, like that. Then I can get rid of this, but those are also important in a case where you see that, okay, here I can plug in the values, I'll be able to find the answers. So I'll get the square root v will be equal to, so how fast the bulb will be revolving is given by this formula. That's how we derive this formula. And don't just come and put this formula and we expect 10 marks. No. You have to show it by coming up with a free body diagram first and derive the formula. It's also, this 10 marks, driving formula is also part of 10 marks. In this case, the question was, okay, but before we answer this question, sometimes they can also ask you to find the period. Now, we know that v, when an object is moving around the circle, then this is true. V is equal to 2 pi r divided by t. Now the time, this starts from here. Velocity is equal to distance over time. The distance is the circumference of the circle. Circumference of the circle is 2 pi r divided by the time. The time is the period. The time it takes to complete one cycle is the period. So again, we can clearly see that v can also be given by 2 pi r divided by t. Now, when you find your v, when you want to find the period, you can come here and plug in the values. Sometimes they can also ask you to find the what? They can also ask you to find the frequency. Frequency is 1 over period. I can modify this and say v will be equal to 2 pi r times 1 over period. I can replace this by frequency. So I can say v is equal to 2 pi times frequency. Again, this is also true. Oh, I have r. Sorry, I've forgotten r. Now, in a case where you don't have the radius, but you have got the length, you come here and use SOHCAHTOA to say this is going to be your radius, but you have the length. So you say sin theta will be equal to, the opposite is r, hypotenuse is l. L they are going to give you. So radius can be given by length times sin theta. And you have L, you have the theta. You can find the radius. Guys, the explanation which I've given you here, you can answer any question. Any question. What do I mean? Any question. Any question for conical pendulum. Now let's read this question. A small body of mass m revolves in a horizontal circle at a constant speed at the end of the string of the length 1.2 meters. As the body revolves, the string as okay. As the body revolves, the string describes the surface of the light circular cone. If the angle between the vertical and the side of the cone is 30 degrees, calculate the speed of the body in meters per second and in rad per second. What are they asking us? They're asking us to find the linear velocity and the angular velocity. Okay? And the time, okay, and the time the body takes to complete one revolution. Have you seen now? That is the period now. The time it takes to complete one revolution, that's the period. So they're asking us to find the angular velocity, angular speed, or angular velocity, linear velocity, and the time it takes to complete one revolution. The time it takes to complete one revolution is the same as the time it takes to complete one cycle, which is the period in this case. Now let's first start by finding the linear velocity. So now you first have to derive this formula like the way we have done it. So now we have come up with what? With this formula. Let's not forget. We have come up with this formula. Now we have to plug in the values here. So V will be equal to the square root of my R is L sine theta times G, okay, times G and then times tan theta. Or if you want, you can find R on separate to make things simple. Okay, to make things simple, we can say my R will be equal to my L is 1.2 sine 30. What will be our R? Those having calculators? Hmm? 0. What? 6? 0.625 or 0.6? Just 0.6. So 0.6 meters. That is now my radius. So I'll come here and now plug in the values. So I'll say my radius is 0.6. Then my G is 9.8 times tan 30. What will be the answer here? The problem is that I don't have a calculator, and if you give me the wrong answer, meaning for the next 3 years people will be just getting that answer because they will be watching this. I don't know where my calculator is. So I want you to give me the okay, I want 3 people to confirm if the answer is correct. 1 point what? Is that correct? The moment you give me different answers, the hope is gone. Ah. So, okay, others, what are you finding? Hmm? You don't have calculators. Eh? 2 people are finding 3.4. Again, 2 people are finding 1.8. So what are we going to do? Which one is correct? Eh? Hmm? Which one is correct? Oh, okay, I see. 1.84 meters per second. Guys, this is the linear velocity. Then again, they are saying Just ask. I'll not be able to see your hand. You can ask if you've got a question. Now, the question again here was find the velocity, find the speed of the body, or calculate the speed of the body both in meters per second and rad per second. Meaning it's the angular velocity and linear velocity. This is linear velocity. To find the angular velocity, I gave you simple formula. What formula is that? If you can remember. Hmm? Okay, yes. I said V is equal to WR. Divide both sides by R, divide both sides by R. That's why I said you can't run away from those formulas, the three. These three formulas, you can't run away from these. You have just to know it. There is no exam. There is no exam without using these formulas. So if you're going to write your SAP and you're not going to use these formulas, just know that somewhere there's something fishing. These formulas are very important. There is no exam without you using these formulas. There is no test without you using these formulas, as long as the topic is the same topic. So I'll have now this will be equal to V over R. My V is 1.84. My radius is 0.6. What is my angular velocity? 1.84 divided by 0.6. 3.07 rad per second. I'm done. The next question was, and the time the body takes to complete one cycle. The time it takes to complete one cycle is the period. The period, you make T as a subject of formula here. Okay? So, if I make T as a subject of formula there, I can clearly see that I'll have, if I cross multiply, I'll have Vt will be equal to 2 pi r. Divide both sides by V, both sides by V. So T will be equal to 2 pi r divided by V. Plug in the values. 2 pi, the radius was 0.6. Divide it by the velocity, which is 1.84. What is the period? 2 times pi times 0.6 divided by 1.8. I want 3 people or 4 people to give me answers. Sorry? 2.05 seconds. So it took about 2.05 to complete one revolution. Guys, the information I've given you right now, the data I've given you right now, you can solve any question for conical pendulum. Now, this guy so-called conical pendulum, if you log in on our website, there is a part on past papers. There is a part where I said conical pendulum past papers. All the questions for conical pendulum, including this question, because this question they got it from 2019, including this question, I solved it. You get my point, right? So for you to understand, okay, for you to come across different questions, if you have got Dafroid, you can solve those questions from Dafroid. Okay, at the same time you can go through that video and then you'll be able to see how I was solving the questions. Now the best thing to do is when you're watching that video, pause the video, solve the question, see, and pause then again continue watching the video. If you'll be able to find the same answer. You understand? Hmm? Yes. This is what I had for you this evening. Tomorrow I want us to focus on work energy and power and static equilibrium. Like I've said, no more excuses. We are back.